Okay, it is done. So okay, so hexagonal prism is given. The base is 40 millimeter and height 60 millimeter is given. So first, so as we have discussed in the previous classes, we have to draw the rough top view and front view of this. So first, let us draw the top view, that is hexagon. In any the condition you can write, either the edge condition or the corner condition you can write. So here I have taken the edge condition. Draw the hexagon of 40 millimeter side is given. So you take a 40 millimeter radius and draw the circle and construct the hexagon. So after constructing the hexagon, enclose the hexagon inside the box. That means from point 3, I have named it as a 1, 2, 3, 4, 5, 6. You draw the horizontal projector on either side, and 4, 5 you draw the vertical projector up and down, and from 6 you draw the horizontal projector on either side, and from 1, 2 you draw the vertical projectors on either side, and then complete this outer box. I have named it as the PQRS, the outer box. First we'll and also draw the vertical projector from all these points till it meets the XY line, and from XY line above that you take height of the hexagon prism, that is 60 millimeter, and it look like a rectangle. Okay, and coming to the isometric position, as usual you draw the horizontal projector. As usual you take any one of the point. I have taken that point as the P. So draw the 30-degree line on either side of this point, and then after drawing the 30-degree line, so you measure this PQ distance and P to S distance, convert that into isometric scale. So this PQ distance you measure and convert that into isometric scale. P as the center, you cut this 30-degree line. You call that as the Q. Next, P to S, take the isometric scale P and cut this 30-degree line. We call this as the S. Next, from S, you draw the parallel line to PQ or 30-degree right side, and from Q, you draw the parallel line to PS or 30-degree left side. Wherever these two, the lines meet, we call this the intersection point, that is W. So that is PQR. Okay, see it is R. By mistake, it is taken as W, R. So outer the rectangle, so I have drawn the isometric projection. So later, what you have to do, from P to 1, you take this distance, convert this into isometric scale, P, and cut this. Similarly, S to 2 distance also same, convert that into isometric scale. From S, you cut this. Similarly, R to 4 distance and Q to 5 distance is same, convert this to isometric scale. You cut it on either side. So you're going to get 1, 2, 4, 5. Next, to get 3, S to this distance you take, S to 3, you cut this, and P to 6 you take, P as the center, 6 you take this, and then after marking all the 6 points, so you join it 1, 2, 3, 4, 5, 6. So you're going to get the hexagon isometric portion of the X, that is base of the hexagon prism is ready. That's all. So after this, what you have to do? So 1, 2, 3, 4, 5, 6, total 6 points are there. You need to draw the vertical projector from all these 6 points, and that vertical projector height is equal to the isometric height of the your prism. What is the isometric height of the prism? 60 millimeter. You take ISO 60 millimeter, you draw vertical projector from all the 6 points and cut it. So see, so just observe the cursor. One you can draw, 2, 3, 4, 5, and 6. This height should be equal to isometric 60. And then name the corresponding points as the A, B, C, D, E, F, or you can name any corresponding points you can give. After naming these points, you join these points which I have named here, A, B, C, D, E, F. Okay, like this. So one more hexagon you are going to get at the top. So this completes your the isometric version of the whole the hexagonal prism, both the top face as well as the bottom face. So finally, as the isometric rule says, so we have to retain the visible edges with the continuous thick line, and hidden edges with the either we can remove those edges, or else we can indicate those edges with the hidden edges. That's what here you can see. Always the in the isometric position, top face completely we can see. The bottom face here, as we can see here, only 3 edges you can see. These 3 bottom face edges we cannot see. You put it in terms of the hidden edges. Next, you draw the vertical projector. So these 2 vertical projectors also it is hidden. So you put it in the hidden edges only. So this how we can complete the isometric projection of the hexagonal prism, which is similar to the your pentagon prism. So the last one. So we're going to discuss under this the prisms, that is solids, that is the cylinder. So cylinder also comes under your prism, because a cylinder is a circular prism you can call, because it has got 2 circular faces, the bottom as well as the top, like this. So for this also, what is the question is given? Draw the isometric projection of a cylinder of side of base 50 millimeter and height 70 millimeter when its axis is vertical. It is given. So as usual, you draw the top view, that is a circle which is equal to the radius 25 or the diameter 50 millimeter. You draw a circle first. So in the top view, it look like a circle, and draw the vertical projector from this the outermost the point, that is you have to draw the tangent, or else before that you have to enclose the circle within the square box, that is at the box method. So from this you draw a tangent on either side. From this point you draw the horizontal projector or tangent on either side. From this point you draw the vertical projector on either side, and from this point you draw the vertical projector on either side. You will going to get the outer square, that is 1, 2, 3, 4. 1, 2, 3, 4 you will going to get. So from here, so to draw the front view, it look like the rectangle. So height of the cylinder is 70 millimeter. You draw the vertical projector from here. So from here you take 70 millimeter and construct the rectangle. So this completes your the front view also. So now I have named this outer box as the 1, 2, 3, 4. First, as usual, we will draw the isometric position for the base of the prism first. So I'll take any one of the horizontal line like this, right side, and I'll take any one of the point and call that as the 1 here for my reference, and I'll draw the 30-degree line on either side of the the point. After drawing the 30-degree line, so 1 to 2, 1 to 4, the distance is same, because it is a cylinder you are enclosing within the box, that is it's a square box. So you convert this into isometric length. 1 as the center, you cut this 30-degree line on either side, same distance. From 1 as the center, you cut it on the left side. That is 2 and 4 point you will going to get. Next, to get the point 3, from point 4 you draw the parallel line to 1 to 2 or 30-degree line right side. Similarly, from point 2 you draw the parallel line to 1, 4 or 30-degree line left side. So wherever these 2 lines meets, this is your point 3. So outer box, so we have completed the isometric projection. Now to get the ellipse inside this, because the circle looks like an ellipse in the isometric projection. Already we have tried in planes. So here 4 center point, the method we will use. How to do that? So let me share here. First, after completion of this outer square box, so I'll draw a horizontal projector from 4 to 2. Like this. This line you can observe here. I'll draw the horizontal line from 4 to 2 first. After this, what I can do, from point 1, I'll draw a line exactly at the midpoint between 4 to 3. So what you can do, from 1 to 4, 4 to 3, 3 to 2 and 2 to 1, you find a midpoint. So from 1, you draw a line exactly midpoint between 4 and 3. Similarly, same point 1, you draw a line exactly midpoint between 3 and 2. Similarly, point 3, you can draw a midpoint between 4 and 1, and point 3, you can draw a midpoint between 1 and 2. Okay, so wherever these 2 lines intersect, you will going to get 1 point, and these 2 lines intersect, you will go into another point, and point 1 and point 3. Total 4 points I will be getting now. PQ 1 and 3 are 4 points from where I have to draw the arc. So from now, after identifying these points, from point 1, you take either 1 to D or 1 to C radius from your compass, 1 to D or 1 to C. From point 1, you draw a arc from D to C like this. This is the arc that you have to draw at the point of 1. Next at point 3, so you take 3 to A as the radius or 3 to B as the radius, 3 as the center, A to B you draw an arc. Okay. After this, from point P, either P to D or P to A as the radius, from P you draw an arc from A to D. Similarly, from point Q, from Q to C, Q to B, to Q as the center, C to B you draw an arc. The total 4 arcs you are drawing, the complete ellipse you can complete like this. So that means with this, the base of the your cylinder is ready. So to complete the cylinder, one more the ellipse you have to draw. So how to do that? So next step is, after this, so from all the 4 points 1, 2, 3, 4. So this is the outer square. From 1, 2, 3, 4, you draw the vertical projector from all the 4 points. You draw the vertical projector like this. That vertical projector is equal to the height of the cylinder. That is isometric 70 you have to take. From all the 4 points, you draw the vertical lines like this. 1, 2, 3, 4 same points you can give. And now after drawing that vertical projector line, you join these 4 points and one more square you will going to get at the top. So this is the square what you will going to get at the top. Once again you repeat this procedure to get the ellipse over here. How to repeat the procedure? From this as the center, so you draw a line till it meets the midpoint between 4 to 3. Similarly, from this point you draw a line between the midpoint between 3 to 2. Similarly, from this point 3 you draw a line between the 4 and 3 midpoint, and from point 3 once again you draw a line between the midpoint of 2 and 1 like this. So now 1, 2, 3, 4, 4 points you are going to get once again. So now you repeat the same procedure to draw the ellipse. From this as the center, either this or this as the radius, you draw an arc from here to here. Okay, from point 3, either this or this as the radius, you draw an arc from here to here. Next, from this intersection, either this or this as the radius, you draw an arc this portion. From this intersection point, from either this or this as the radius, you draw an arc. So once again, the complete the ellipse, okay, you can get it. So after getting both the ellipse, this is the top portion of the ellipse, this is the bottom portion of your the ellipse. Now you can draw a tangent. You can draw a tangent from this ellipse to this ellipse vertically like this. You draw a vertical line from this end point to this end point, from this end point to this end point. So this completes your isometric projection of your the cylinder. So now, so how exactly it looks at the end, you can see here. So here also cylinder, when it is tilted like this, cylinder, the complete top face you can see. So this is your top face, the completely the ellipse you can see, and here the bottom portion, half of the your ellipse you can see, the remaining half, that is the base half, you cannot see. That's why I have made it the hidden edges. So this completes your isometric projection of the the cylinder also. Okay, so total how many prisms in solids, how many examples we have discussed? We started with the cube we have discussed, and square prism, rectangular prism, pentagon prism, hexagon prism, and even the cylinder also we have discussed. So these assignments already have posted in Edge. Okay, the deadline also it is given, and also PPT also have shared. So you have to complete this and you have to update me. Okay, any doubts in these two, you can chat me so that I can get back to you. Any doubts about these two? Square pyramid. Okay, square pyramid. When it Look, when you look from the top, it look like a square. Square pyramid means it has got a square base, wherein all the four sides are equal. So here the dimension is given, the isometric projection of the square pyramid of base 30 millimeter and height 55 millimeter. So 30 millimeter is the your side and height is 55 millimeter. So you draw a square in the top view of 30 millimeter, and I have named it for my convenient ABCD. And in front to the square pyramid look like a isosceles triangle. Okay, how to draw this? So you draw the vertical projector from this till it meets this XY line, and from here you take the height, that is 55 millimeter is given, and draw the midpoint. Draw one line. So then from the midpoint of this you draw a line. Wherever it meets the 55 millimeter line, you connect it. So your triangle, isosceles triangle is ready in the front view. Okay. So now let us start the isometric portion of the pyramid. So your top view is ready with you. Draw a horizontal line like this, and take any one point here. So my convenience, I am calling it as A, and draw 30-degree line on either side. 30-degree line on either side. A to B and A to D distance is same because it's a square. You convert that into isometric scale. You cut on either side of your 30-degree line. You will going to get B as well as D. You will going to get. Okay. So then from point D, so all of you are familiar with this. Draw a parallel line to AB or right side 30-degree line. From point B, you draw a parallel line to AD or left side 30-degree line like this. Wherever these two lines meet, so that intersection, you can call it as C. So the base of the pyramid is ready. So now the next question arises, how to draw the isometric portion of the pyramid. So once you complete this, next step is you draw the, you join D to B and C to A. You join this diagonals D to B and C to A. So the intersection of that is the center point of the base of the pyramid. Okay, in the pyramid, the axis point always, okay, it will be a line, imaginary line between the center of the base to the apex. So that is called as the axis. The height has to be measured always the axis only. So that means you find out the center of the base by drawing the diagonals. That is A to C, D to B line. You join it like this. You can join D to B and C to A. This is the intersection. Correct? So this is the center of your base of your square pyramid. You call it as this as the oval. So that is the base center point. From this oval, you draw a vertical projector line, and this vertical projector line should be equal to the axis of your pyramid. Axis, how much it is given? 55. That means you take isometric scale of axis, that is height. From O1 you cut this vertical line, isometric 55, and that point is nothing but your apex point or the vertex point of the pyramid. You call this as the O. Now as I told in the pyramid, so the apex point should be joined, or the vertex point should be joined to all the corners of your the base of your pyramid. Here how many corners are there in square pyramid? 4 corners are there. So now from this apex point you join a line to all the four corners like this. If you join it, so then the isometric portion of the square pyramid is ready. Next, how it looks. So here the base is concerned, only this and this you can see. The other two, the base side you cannot see, it is behind you. And coming to this slant edges, these two slant edges are seen. It becomes outermost boundary lines, and this also. Whereas from here to here, the slant edge you cannot see because it will coincide with this. So that's why only these two base edges are hidden edges. So like this. So you have to draw the isometric portion of the pyramids, and the same procedure holds good for rest of the pyramids also. Coming to the second one. So this is draw the isometric position of the rectangular pyramid of side of base 50 by 40 millimeter and height 75 millimeter when its axis is vertical is given. So you draw a rectangle. So that is left to you whether you take the shorter edge left side or longer edge left side. I have drawn this rectangular pyramid. In the top view it look like a rectangle. that is 40 by 50. I have taken shorter edge left side and longer edge right side. Draw the vertical projectors here till it meets this XY line. Next, from here you take the height of the pyramid, that is 75 millimeter, and draw a horizontal line. From the center, you draw a vertical line. Wherever it meets the 75 millimeter, that is your apex point. You join it to the both this end points. So your front view, that is isosceles triangle, is ready. Next, how to draw the isometric version of the rectangular pyramid. First, right side you draw the horizontal projector line like this. Call this as any one point, that is point A. So from A you draw the 30-degree line right side and 30-degree on left side. From A to B you take this 50 millimeter and convert that into isometric scale. From A as the center 30 and the 30-degree line you can cut, you call that as the B. Similarly, A to D 40 millimeter, you convert that into isometric scale. From A as the center, you cut the left side of 30-degree line, that is AD. Okay, so you're going to get this D also. From D now, you draw a parallel line to AB or 30-degree line right side. Similarly, from point B, you draw a parallel line to AD or the 30-degree line left side. Wherever these two intersection lines, the lines intersects, so you call that as the point C. So your base of your the rectangular pyramid is ready. So after this, how to find out the center of the base? Draw a diagonal from D to B and C to A. So that becomes the center of your base. Like this, we can draw a diagonal A to C and B to D. This is your base center. From this center, O1, you call that as the O1, you draw a vertical projector line. You draw a vertical projector line. And this vertical projector line, you take height of the pyramid, that is 75 millimeter. Convert that into isometric scale. From this O1, you cut this vertical projector line and call it as the O. That is the apex or the vertex point. So as usual, after getting this vertex or the apex point, all the corners should be joined. Okay. So O to A you can join, O to D, O to C, and O to B you can join. So all the corners to be joined to your vertex. And at the end, how to retain the visible and hidden edges? So the base edges 1 and 2 you can see, you make it the thick. The remaining these two edges you cannot see, it is hidden edges. Okay. Now the slant edges from here to here, here to here, here, these three you can see. You cannot see this slant edge. It has to be hidden edges. So like this, you're going to get your the isometric position of the rectangular pyramid. Okay, so these are the things we have discussed today. So next class we'll complete the pyramid and then we'll start the